Hello students, today I am going to start chapter 7 Sets. Let us introduce the chapter. In the previous classes, we have learned about sets and the operations that can be performed on them. We shall carry our study of sets further in this chapter, but let us first recall what we already know about sets. We know that set is a well-defined collection of distinct objects. So what is well-defined and distinct objects? Well-defined means the members of a set should be so precise that we should be able to identify them. And the distinct objects are elements are different from each other, or there should not be any repetition of elements in a set. Now how to denote the sets? We know that W represents whole numbers, N represents natural numbers. So these two sets can be respectively written as follows: W equals to, in curly bracket, 0, 1, 2, 3 and so on, and natural numbers are written in curly bracket 1, 2, 3, 4 and so on. Thus we denote a set by capital letters and its elements are listed within the curly bracket. These are the elements of the sets and they are separated by commas. Now representation of a set. There are three ways to represent a set. First is description method. Second is roster method or tabular method, or we call it listing method. And third is set builder method. In description method, the elements of a set are described in words and this description is enclosed in curly bracket. For example, the set of all schools in Jaipur is written as all schools of Jaipur. Let's take another example. The set of prime numbers less than 100. So we write here prime numbers less than 100. So we describe these sets in words in description method. In roster method, all the elements of a set are listed within curly bracket and are separated by commas. For example, a set A of the month having only 30 days. So these months are April, June, then September and November. Let us take another example. Set of natural numbers less than 6. We write 1, 2, 3, 4 and 5. So in roster or tabular listing method, we write the elements separately and from each element we write commas. They are separated by commas. Now set builder method is also called rule method. We define a set with a rule and the whole description is enclosed within curly bracket. Let us do one example. Set A, the number of elements in this set are the natural numbers less than 10. So we write here x such that x belongs to natural number and x is less than 10. So we use here rule or property. Now next is cardinal number of a set. Cardinal number of a set is the number of elements present in a set. Symbolically we write a cardinal number of, suppose set A is cardinal number of A. And for take example, if A equals to 1, 2, 3, 4, 5, 6, 7, 8 elements. So cardinal number of A is 8. Now this is all about cardinal number of a set. Next is types of sets. First is finite and second is infinite. In finite set, all the members are countable. That is, just take one example, the set of months in a year. So the month in a year form a finite sets because they are countable, and we write here any set A and its months are January to December. These are countable, so it is a finite set. In infinite set, the elements are not countable, so it is infinite. Let us take one example, set of natural numbers 1, 2, 3, 4, 5 and so on. So on means infinite. So this set B is called infinite set. Now next is singleton set. Singleton means 1. So in singleton set, a set that has only one element is called singleton set, and cardinal number of singleton set is 1. The set of natural, for example, the set of natural numbers less than 2. Natural number less than 2 are only 1. So it is a singleton set and cardinal number of this set is 1. Now next is null set. It is also called empty set. A set that does not contain any elements is called null sets or empty set. Its symbol is phi or only this curly bracket, and cardinal number of this set is 0. Let's take example, a set of natural number less than 1. Set of natural number less than 1 is not possible because no such number is possible. So this set is empty set or null set. Next is equal sets. Two sets are said to be equal if they have the exactly same elements. It is written as A equals to B. If they are equal, if they are not equal, it is written as A is not equals to B. Just take example. Letter set A has letters of the word God. It is written in roster form G, O, D. And set B has letters of the word good. Letters are G, O, D. Because O is not repeated here, so these two sets are equal sets. So you write A equals to B. Next is equivalent sets. Two sets are said to be equivalent if they have the same number of elements, not the exactly same. Only the numbers of elements are equal. And cardinal number of both the sets are equal in equivalent sets. For example, A equals to 1, 2, 3, 3 elements, and cardinal number of A is 3, and set B has elements 4, 5, 6, and cardinal number of B is also 3. So these two sets A and B are equivalent, and we denote it using this sign. A is equivalent to B. Next is overlapping or joint set. Two sets are said to be overlapping or joint sets if at least one element is common in both the sets. It may be 2, 3 or more. For example, set A has elements 1, 2 and 3. Set B has elements 3, 4 and 5. So in both the sets 3 is common. So these two sets are called overlapping sets. Next is disjoint sets. Two sets are said to be disjoint sets if they don't have any element common. For example, set A has elements 2, 4 and 6. Set B has elements 1, 3 and 5. In both these sets, no element is common, so these two sets are called disjoint sets. Next is universal set. Let us understand what are universal sets. Taking example, let us set A is a set of even natural numbers and set B has set of odd natural numbers. And universal set as we write set of all natural numbers. All natural numbers contains even natural numbers and odd natural numbers included. So in universal set, all the elements of the sets A and B under consideration is called universal set. It is denoted as capital U or Greek letter Xi. Now next is subsets. If a set P has elements A, E, I, O, U and set Q has all letters of English alphabets, or we can write here set of English alphabets. So the set, all the elements of P are also the elements of Q. So we call here P is a subset of Q and it is denoted using this sign. P is a subset of Q and thus Q is said to be superset of P. Note that every set is a subset of itself and the null set is also the subset of set.